Assalamualaikum everyone. We are starting with questions related with trigonometric equations. Now, trigonometric equations could involve a lot of things. It could involve a lot of simplification. It could involve a lot of algebra. It could be about algebraic expansion. It could be about factorization. It could be about taking LCM. Naturally, it also will involve trig identities. And when we talk about trig IDs, it could be the basic ID, that is sine squared theta plus cosine squared theta equals to 1. Or it could be about tangent theta equals to sine theta over cosine theta. And when we talk about factorization, so it could be taking common, that is factorization. Middle term factorization is also factorization. A square minus b square, that is a plus b, a minus b, that is difference of two squares, that is also factorization. Now, if I talk about this thing, that is we could be working, when we are talking about trig equations, we could be working in degrees, we could be working in radians. In degrees, work in 2 decimal places if the answer is not exact. Work in 2 decimal places so that the final answer should be given to 1 dp. And over here in radians, let me just open up the camera. Let's see how it goes. So now in radians, we should work in 4 significant figures so that the final answer should be given to 3 SF. So that is the basic idea that we work with. Naturally, you should remember the quadrants and all these things. And let me just label it. We know that all the trig ratios are positive in the first quadrant, only sine, only tan, only cosine. In the first quadrant, theta is alpha. In the second quadrant, theta is 180 degrees minus alpha. In the third quadrant, theta is 180 degrees plus alpha. In the fourth quadrant, theta is 360 degrees minus alpha. And also remember that pi is 180 degrees and pi into 2, that is 360 degrees. Pi can also be written as 3.142. 2 pi will be written as 6.284. So that is the basic thing that we are working with. Now let's go down to each single question and let's see how it goes. It says solve the equation. This is the equation and this is the range of values. So it says sine 2x plus 3 cosine 2x is equals to 0. So sine 2x is equals to negative 3 cosine 2x. Divide both sides by cosine 2x. Divide by cosine 2x. So now as long as this angle is the same, that's not an issue whether this is 2x, whether it's x and x, whether this is x plus 10 degrees, x plus 10 degrees. So sine over cos is tangent. So therefore what do we have? We have tangent to x is equals to negative 3. So that is the step that we will start working. First of all, modify the range, or even before that, the quadrant, that is first and third, that is positive. So this is second and fourth, that is for the negative value of tangent. That's right over here. First and third, that's positive, therefore second and fourth. In second, 180 minus, in fourth, 360 minus the basic angle. So now the next step is our tangent. Alpha is equals to positive 3, we always calculate it with a positive ratio. But isn't it a good idea that first let's write down the modification of the range. 2x lies between 0 into 2 is 0 degrees and 182 into 2 is 360 degrees. So we are talking about one complete revolution and our answer will lie within that range. Tangent alpha is positive 3. Therefore, alpha is tan inverse of 3. Now, all the people who are good with the calculator, just work it out. This comes out to be, I think, 71.57 degrees. That is the basic angle. If I'm not mistaken, alpha comes out to be 71.57 degrees. I'm working in 2dp, that is alpha. And then it says we are working for 2x. So therefore, working towards the final answer, 2x equals to, in the second quadrant, it's 180 minus 71.57. And in the fourth quadrant, this is 360 minus 71.57. Make a habit of writing the degree notation. Make x the subject, that is 180 minus 71.57 divided by 2. This is 360 minus 71.57 divided by 2. And your final answer is written over here, 54.2, 144.2. This is 54.2, 144.2. This is given correct to 1 dp. So now this is the first question. Go to your WhatsApp. And this is question number 9 that I started with. So question 9 is the first one. Is it all good, all clear? Just acknowledge it over there. I think it's a pretty basic kind of a question. So I'll just wait for responses. I think it's pretty much understood. We are following exactly what we have done in our classes. And the mark scheme is right over here, so we can just double check. So now let me get started with the other one. That is question number 2, and that's pencil. Okay, so now question number 12, that is question number 2 in series, and the theta lies between, or x lies between 0 and 180. So now let me label one other thing. That is this first question. This question is in degrees. Now red is for degree. This question is also in degrees. And solve the equation 3 tangent 2x plus 15 degrees is equals to 4. 3 tangent 2x plus 15 degrees is equals to 4. Tangent 2x plus 15 degrees is equals to 4 over 3. Now it's a beautiful coincidence that today in class when we were solving this question, 4 over 3 was, we were working with this number 4 over 3 and 3 over 4, but it was in radians, and now we are working in our degrees. So now from this point onwards, we are starting with the 4-step method. And what is the 4-step method? That is that we are starting the first step, that is tangent is positive. So tangent is positive in which 2 quadrants? In the first quadrant, in the third quadrant. The second thing, that is modification of the range. X lies between 0 and 180 degrees. 2x lies between 0 and 360 degrees. 2x plus 15 degrees lies between 15 degrees and 360 plus 15, 375 degrees. Now somebody could raise this question that what's the use of doing all this? Why do we modify this range? We modify this range because if any answer in the intermediate stage is exceeding this range, we have to cancel it. Well, at the moment, it did not arise in such a way. 180 minus 71.57 was between 0 and 360. This was also between 0 and 360. But if such an instance occur, we would cancel and look for an alternate. So over here, we have reached this stage. Now the next one, let alpha be the basic angle. What is the definition of the basic angle? That is the acute angle with x-axis. Tangent alpha is 4 over 3. If I'm not mistaken, this comes out to be 53.13 degrees. Yeah, there it is. So therefore, this basic angle comes out to be 53.13 degrees. Now we are dealing with the first quadrant and the third quadrant. So therefore, let me write it down. 2x plus 15 degrees, working towards the final answer. In the first quadrant, this is 53.13. In the third quadrant, 180 plus 53.13. Now just pause for a second and let's have a look over here. So are these two values that we have obtained so far, do they lie within this range, 15 and 375? Yes, they lie within the range. So then there is no issue. Just continue with the working. Now with the working, we want to make x the subject. So what should we do? Transfer the 15 to the other side, the positive becomes negative. So first step, 2x is equals to 53.13 degrees minus 15 degrees, and this is 180 plus 53.13 degrees minus 15 degrees. And then what will we do? We will divide by 2, we will divide by 2, we will divide by 2. Now we will use the calculator and we will write the final answer correct to 1 dp. Let me pick the answer from here. That's 19.1 and 109.1. So this is 19.1 degrees, 109.1 degrees. This is correct to 1 decimal place. So question number 2 is basically question number 12. And if there is any issue, if there is any confusion, just put a question mark in the comment, so I'll understand that there is an issue. A thumbs up or a tick mark, that is perfectly good. A star is even better. I would be very, very motivated. And I think that's how this is. I'll just pause for it. And let me beautify this thing in the meanwhile. So question number 12 is all good, all clear. Let's move on. Question number 18. Again, this is in degrees. So let me write in red color. This is degrees. How do I know? I look at this. So now this is question 18. Show that the equation can be written in this form. That's the first part. Hence solve this equation. So let's start with the first part. Now the first part is you have to use some identity kind of thing. So 2 tangent square theta sine square theta equals to 1 can be written in this form. So what will we do? We will write tangent theta equals to sine theta over cos theta. If I square both sides, what do I get? This is sine square theta, cos square theta, that is tan square theta. The 2 is still there, sine square theta still there, equals to 1. So now I'll multiply this thing like x square into x square, that is x4. Sine square into sine square, that is sine power 4 theta, and this cos theta. Cos square theta will be taken to the other side. 2 sine power 4 theta is equals to cos square theta. But we also know the fact sine square theta plus cosine square theta equals to 1. Therefore, sine square theta is 1 minus cosine square theta. So now cosine square theta is written as 1 minus sine square theta. Just have a good look at what I've done. I have used two identities. Tangent is sine over cos, so tan square is sine square over cos square. I multiplied, I cross multiplied, I used the identity, the last one in purple, I replaced cos square theta with 1 minus sine square theta. Now transfer all the terms to the left hand side. So this is 2 sine power 4 theta plus sine square theta minus 1 equals to 0, and this is what you have obtained. So let me highlight this thing. The first part is all done, all clear. So what we get is a disguised quadratic equation. 2 sine power 4 theta plus sine square theta minus 1. So let me grab this thing from here. Let me add a page over here. And let me continue with this. So now over here, if I work this out, hence solve this equation for 0 till 360, and that equation is this. So basically we will write 2 sine power 4 theta plus sine square theta minus 1 equals to 0. This is a disguised quadratic equation. What is a disguised quadratic equation? The power of the highest power and the second highest power, it's in a ratio of 2:1. Ax square plus bx plus c equals to 0. So let's make a substitution. Let me write, let m equals to sine square theta. And keep in mind, you are looking at this kind of question for the very first time. In the next week, we will be studying quadratics. So we'll be studying this in much detail. M is sine square theta, therefore square both sides. M square is sine square theta whole square, which is sine power 4 theta. So therefore 2m square plus m minus 1 equals to 0. Solve for m. When we solve for m, that is 2m square plus 2m minus 1 equals to 0. 2m common, m plus 1 minus 1 common, m plus 1 equals to 0. Therefore, m plus 1, that is this thing, m plus 1, and this is 2m minus 1 equals to 0. Therefore, m plus 1 equals to 0, m is negative 1, 2m minus 1 equals to 0, therefore m is positive half. I think that's pretty basic. But what is m? M is sine square theta. So therefore sine square theta equals to negative 1, sine square theta equals to positive half, sine theta on the left hand side equals to square root of negative 1. No solution. You cannot take square root of a negative number. Sine square theta is equals to 1 over 2. Therefore, sine theta is plus minus 1 over 2 square root. That is plus minus 1 over root 2. That's the value of sine theta. Now, just go over this thing first. I'm just minimizing it. So, I'm giving you a full idea how this thing came into being. You got a quadratic equation right over here. That was for 2 marks. Now this is for 4 marks. Actually, in my view, it's worth more than 4 marks. You started with this. You made a substitution. You first realization. That is something very important. Realization that it's a disguised quadratic equation. What's a disguised quadratic equation? The highest power, the most highest power, and the second highest power. That is in a ratio of 2:1. So what we do is that we make a substitution. So let me just pause for Azan. I'll just pause for a second. Okay, so let's continue. So sine has a maximum value of 1, a minimum value of negative 1, but that's not the issue over here. The issue over here is you cannot take the square root of a negative number. That's why no solution. And over here, when you took the square root, this is a special number that we deal with. Which special number am I talking about? So let me draw a box over here. And let me remind you a box that is shaded. And that goes like this. That is sine of pi by 6. Actually, let me write in degrees right now. Sine of 30 degrees is half, which is cosine of 60 degrees. Sine of 60 degrees is square root 3 over 2, which is cosine of 30 degrees. and sine of 45 degrees, that is 1 over root 2, which is cosine of 45 degrees. There are some values of tangent also, but that's not the issue over here. Let me not get distracted and focus over here. So therefore the basic angle is 45 degrees. Now I'll start the 4-step process over here, and let's see how it goes. So now first of all, sine theta is equals to plus minus 1 over root 2. The answer is in all 4 quadrants. And the next thing, what is the range? The range is 0 till 360 inclusive. Theta lies between 0 till 360 degrees inclusive. Let alpha be the basic angle. Sine of alpha is 1 over root 2. Therefore, alpha is 45 degrees. And then the final answer, theta is 45 in the first quadrant, 180 minus 45 in the second, 180 plus 45 in the third, and 360 minus 45 in the fourth. So the final answer, if I'm not mistaken, I hope so, that's 135 and 225 and 315. Let me go to the mark scheme, and this is all good, all clear. First, second, third, and fourth, just write theta once, and 4 answers are over there. So I hope this is all good, all clear, and this is question number 18. Let me write over here. So question 18, it's all good, all clear. Okay, AS1, AS2, and it's all good. Let's move on. Now another question of degrees, and let's go very easy on the things. It is given that A is sine theta minus 3 cos theta. B is 3 sine theta plus cos theta. Theta lies between 0 and 360 degrees. The first part is show that a square plus b square has a constant value for all values of theta. We are doing it for the second time. And last but not the least, find the values of theta for which 2a is equals to b. So first of all, if I get started with this thing, that is constant for all values of theta. So the first part, that is like a proof. Now a is 3s minus 3c, s minus 3c. And b is 3s plus c. What is s? So I am writing, let s denote sine theta. Let c denote cosine theta. If I can convey it to the examiner at the onset, at the beginning, that is perfectly fine. So just reduce your working where possible. A square, that is s minus 3c whole square. That is s square minus 6c plus 9c square. And b square is 3s plus c whole square, which is 9s square plus 6sc. That is not c, that is sc, my bad. So this is sc, okay, and this is c square. I hope it's all good, all clear. Now if I add a square plus b square, what will happen? This negative 6sc, this positive 6sc will cancel. S square will be added to s square. C square will be added to c square. So that is 10c square. And this is 10s square. So therefore, I'll take 10 common out. This is s square plus c square. Remember the identity. Sine square plus cos square equals to 1. That is 10 into 1, which comes out to be 10. I have proven the point that it's constant for all values of theta. I can even say it's independent of theta. So I think this is all good, all clear. And let me just continue with the working. Okay, let me just have a look over here. Okay, so now it says find the values of theta. That's the green thing. Find the values of theta for which 2a is equals to b, and this is the range. So we have 2a is equals to b, 2 times sine theta minus 3 cosine theta equals to b, which is 3 sine theta plus cosine theta. Open up the brackets. That is 2 sine theta minus 6 cosine theta. This is 3 sine theta plus cosine theta. Let me adjust the pencil for a second. Okay. So now this is 2 sine, 3 sine, that is negative sine theta. This is negative 6 cosine theta. This is positive cosine theta. Taken to the other side, that is positive 7 cosine theta. Divide by cosine theta, divide by cosine theta. So therefore we have negative tangent theta equals to 7. Now kind of looks weird. Let me just double check my working. Usually we don't get such a high value, but everything is possible. 2 into sine, 2 into minus 3. 2 sine minus 3. That's good. That's 3 sine plus cos. A is sine minus 3 cos. Sine minus 3 cos. B is 3 sine plus cos. 3 sine plus cos. That's good. That is 2 minus 3 is negative 1. That is okay. And 1 plus 6, that is 7. I think it looks good. Therefore, tangent theta equals to 7. Now, no harm in double checking. Okay, there it is. So now, yes, you can get some answer which are not so mainstream. They'll look different because normally tangent theta, the value comes out to be like 2, 3, but this time it came out to be 7. It's very strange. So now let's start the 4-step solution. First of all, this is first and the third quadrant. And then modification of the range, there isn't any because it's theta, theta, so no modification. Theta lies between 0 and 360 degrees. And the next one, tangent alpha is positive 7. One more thing, that is negative. So I forgot this negative sign, my bad. I forgot this sign, it just clicked to me. And let me write over here, second and fourth quadrant. So now we calculate using the positive value. Therefore, alpha comes out to be 98.1 degrees. And is it positive 7? Negative 7. Okay, so let me just use my calculator. If any one of you is able to use that. So that is the scientific, clear, and shift tan. Where is the shift? That's the new one. I'm interested in degrees. And second and 7 and tan inverse. Okay, this is something else. I think it's a new version of this thing. So tan inverse 7. Okay, that comes out to be 81.87. So it's not 98.1, it is 81.87. So this is 81.87 degrees. Okay, so far so good. So now theta comes out to be 180 minus 81.87. And this is 360 minus 81.87. And that is the answer that's written over here. That comes out to be 98.1 to 78.1. So this is 98.1 and this is 278.1. This is given correct to 1 decimal place. So that's how this question is done. So now we are done with question number 30. And yes, there are some people who gave me the answer. And thank you for that. This is question number 30. I'm just listing down the questions over here. Okay, so that you have a track of which questions did we do. So now this thing is done and now it's time for radians. So now it's time for RADIANS. So now we'll be starting with this. So let's get started with this. So question number 33. There are two parts, the first part and the second part. So let me just copy it because I'll be needing it. So let me add a page. For the second part. For the first part, now it says find the possible values of x for which sine inverse of x square minus 1 is equals to pi by 3. Now let me remind you of something very, very basic. Let me draw a box over here. Remember from O-level maths, some basic idea. If sine of 30 is equals to 0.5, therefore sine inverse of 0.5 will give me 30 degrees. Very simple. That means if sine inverse of this thing is this angle, in other words, x square minus 1 is sine of pi by 3. So now your calculator should be in the radian mode, or your mind should be in the radian mode, because you should know that pi by 3 is 60 degrees. Sine of 60 degrees, it was mentioned earlier somewhere over here. There it is. Sine of 60 degrees is root 3 over 2. So let me just move over here. So sine of 60 degrees, let me write. Sine of 60 degrees is square root 3 over 2. This is 60 degrees. This is root 3 over 2. This equals to x square minus 1. X square is equals to 1 plus root 3 over 2, which can be written as 2 plus root 3 over 2. That is x square. Therefore, make x the subject. They did not mention, they mentioned something about 3 decimal places. So now take the square root of 2 plus root 3 over 2. That is 2 plus 1.732 over 2 square root. Use a calculator and this answer comes out to be plus minus 1.366. So this is plus minus 1.366 because you're taking the square root. Now another thing that we should remember is this. When we take about square root, we get a plus and a minus sign. And square root can be taken only for positive values. Square root is possible only for positive values. That means the same rule applies for even root, whether it's something raised to power of 1/4 or something raised to power of 1/6 or so on. So something very important, let me write this thing on the side. Now, when we talk about odd roots or cube root, a positive cube root will give me positive, a negative cube root will give me negative. Square root can only be taken for positive values and it will come out to be plus minus. That same thing is true for odd root, whether it's raised to power of 1/5 or raised to power of, this is 4 by the way, or raised to power of 1/7 and so on. So keep this rule in mind. Now it says, find the possible values of x, the second part. Now it says solve this equation, give answer in terms of this. So this is the range, giving theta in terms of pi in your answer. So this is case number 1, that is working in exact form, and exact form over here means in terms of pi. So now solve the equation. Sine 2 theta plus pi by 3 equals to half, and let's start the 4-step solution. The first step, that is sine is positive in first and second quadrant. The second step, that is the modification of the range. Theta lies between 0 and pi. 2 theta lies between 0 and 2 pi. 2 theta plus pi by 3 lies between 0 and 2 pi plus pi by 3. 2 pi plus pi by 3. So now keep that in mind. And let me just highlight this thing. Okay, so working on the sidelines, that is sine alpha equals to half. Therefore, alpha is pi by 6. Now let's get started. And one more thing that I missed, you're adding pi by 3 to both sides. So this is pi by 3. Now this time I feel that something will happen which you have not seen before. Now let's work it out. When we work it out, 2 theta plus pi by 3 equals to pi by 6 and pi minus pi by 6. Now first of all, this thing over here, it's half a revolution. This is from 0 till pi. When we double it, it's a full revolution plus 60 degrees in radians, which is pi by 3. Now, when I look at these first two answers, is any one of them exceeding this range? Yes, this is 30 degrees. The range is starting from 60 and this is 360 plus 60, which is 420. The range is starting from 60, it's not starting from 30. So this first answer needs to be cancelled. That's one way of thinking about it. Let me make you think in another way. Let's say at this point, you did not think about that. You transfer this to the other side, pi by 6 minus pi by 3, this comes out to be negative. How will you deal with this negative answer? Because the final answer should be between 0 and pi. So that means that anything which is outside of the range, this will be rejected. And what is the alternative? The alternative is add 2 pi. Now let me explain to you why am I adding 2 pi. There are so many things on the sidelines over here. Now I'm drawing this line. Let me draw this angle over here, which is the red angle, let's say like this. This thing over here, this is 30 degrees. I'm thinking in terms of degrees right now for simplicity. If I go ahead and go one more revolution and reach this place, this is 30 plus 360 degrees. I'm still in the first quadrant, but I went a little bit overboard. I went one more revolution. If I go one more revolution, therefore this thing in radians is pi by 6 plus 2 pi. So this is rejected. This is the alternate. Now I know that this takes some time for you to digest it, because you have not seen anything like this before. So let's apply all the time that we have over here. The working was sine 2 theta plus pi by 3 is half. You wrote about the quadrants, you modified the range, you doubled it, you add pi by 3, pi by 3, pi by 3 to both sides. Now it's starting from 60 degrees. The basic angle is giving me pi by 6. But this pi by 6 is out of the range, because if I transfer this pi by 3 to the other side, pi by 6 minus pi by 3, that would be negative pi by 6. Divided by this 2, that will give me a negative answer. I don't need a negative answer because my range is from 0 till pi. So this one gets rejected. I find the alternative. Because we are going 360 degrees more, this is just 30 degrees more because of the basic angle. So therefore the alternate is this, the alternate is this. Now work it out. So now I'll write 2 theta plus pi by 3 is equals to 5 pi by 6. And this is 6 into 2 is 12, 12 plus 1 is 13, this is 13 pi by 6. 2 theta equals to 5 pi by 6 minus pi by 3. This is 13 pi by 6 minus pi by 3. And then let me first simplify this. 5 over 6 minus 1/3. 5 over 6 minus 1/3. That is 5 over 6 minus 2/6. That is 3 over 6, which is half. So this is pi by 2, pi by 6. So this comes out to be pi by 6. 5 over 6 pi minus this thing. So let me just double check. This is 1 over 3 is multiplied by 2, multiplied by 2, that's 2 over 6. 5 minus 2 is 3, 3 over 6 is pi by 2. So my bad, let me just correct it. This is pi by 2. And the next one is 13 over 6 minus 1 over 3. That's 13 over 6 minus 2 over 6. 13 minus 2 is, that is 11. That is 11 pi over 6. This is equals to 2 theta. Therefore, make theta the subject. That is pi over 4. and 11 pi by 8. That is the answer. Let me double check. I hope this is all good. Pi by 4, 11 pi by 8. Pi by 4 and 11 pi by 12. Why is it 11 pi by 12? My bad. That is 6 into 2 is not 8. That is 12. So this is 6. This 2 comes down and that is the answer. Now this is the toughest question that you have seen so far. That is question number 33. That is about gradients. That is about first answer getting rejected. Getting rejected. Okay. So let me do one other question like this. AS2, AS1. Okay. So let me explain one other question. Let me also look at the WhatsApp. There is this thing, compound angle, all good. Now let me do one other question like this, question number 33. And that other question should be this one. Okay. Special rejection question. A sine bracket 2 theta plus 40 degrees is equals to 0.5. Theta lies between 0 and 360 degrees. Now this is about 2 revolutions. So it is more or less along the same lines. Okay, let's get started. So first of all, this is first and second quadrant. Second thing, 2 theta lies between 0 and 720. 2 theta plus 40 degrees lies between 40 degrees and 760 degrees. Third step, let alpha be the basic angle. Sine alpha is equals to 0.5. Therefore, alpha comes out to be 30 degrees. Now, working for the final answer, 2 theta plus 40 degrees is equals to. Now, let me draw a small grid over here. Something like this. And let me just draw this thing. Let me draw one other grid. This is 30 degrees right over here. And this green one is 150 degrees right over here because the basic angle is 30. So this is 30 degrees. This is 150 degrees. This is 30. This is 150. And then in the next revolution, 30 plus 360 is 390. And 150 plus 360 is 510. So one more revolution, that is 390 degrees. One more revolution, that is 510 degrees. Now focus on this thing. Is any one of the answer getting rejected? The answers are starting, the intermediate step, it should start from 40, it should go till 360. This first answer is getting rejected. So this is rejected. Now I have the liberty of going way ahead. So let me add 360 degrees more. So 390 plus 360, that is 750, that is within this range. So now let me write over here, which color should I use? Let me use a bluish color. So it goes like this. This is 390 plus 360, that comes out to be 750 degrees. It's within this range. So whenever the first answer gets cut off, you have the liberty of going forward. You add a 360, write one extra solution, doesn't make a difference. At the very end, your answers should lie within 0 to 360, whatever is the given range. So now I'll write 2 theta plus 40 degrees is equals to 150, 390, 510, 750. Therefore, 2 theta equals to 110 degrees, 350 degrees, 470 degrees, 710 degrees. Yeah. So therefore, theta becomes 55 degrees. This is 175 degrees. This is 235 degrees. This is 355 degrees. Your final answer should lie between theta 0 till 360 degrees. So this is a very, very special rejection question in which the first answer gets rejected. When it gets rejected, the solution is go ahead one more revolution. So this is one more revolution that you go. One more revolution means what? You have to add 360 degrees more. So this is the special one. So the special one, and I hope this is all good. Special one. And let me just correct myself. Forward. Okay, so I think the most interesting chapter that we study in pure maths, that is this thing, trigonometry, the most interesting one out of the 3 chapters that we have studied. Okay, another question of radians. So let me write over here in blue color. So now this is radians. How do I know it's a radians question? Because it says over here. So that's the blue color. That's how I know it's in radians. Maybe it's in the exact form. Maybe it's in the decimals form. I don't know. Let me just take a sneak preview. This time it's in decimal form. Okay, so now it's about proving the identity and then working it out. So first of all, part 1, it says, I think this thing is causing trouble. Okay. So now it says tangent x plus 1 divided by bracket sine x tangent x plus cosine x is equals to sine x plus cos x. So we start from the left hand side, which is bigger, and we move to the right hand side, which is smaller. And that is the strategy that we apply when we are out to prove a trig identity. And of course, simplification and all these things are there. So now tangent, that is sine over cos plus 1. Again, let me write, let S for sine x, let me use the symbol C for cosine x. Sometimes they use x, sometimes they use theta. Division, sine x tan x, that is sine, tan is sine over cos plus cos. Now this makes life really simple. And one other thing, that is when you have something in the numerator and something in the denominator. So this is the numerator, that's right over here, and this is the denominator, which is right over here. So write it out separately. This is the denominator, this is the numerator. Write it out separately. That will make life simpler. Something on the side, something on the side. So now over here we have LCM, S plus C over C. Division, and this is S square over C plus C. Now S plus C over C, and this is division. This is S square, the LCM is C, plus C square over C. Now over here, S square plus C square, this is the trig ID, the mother of all identities. This comes out to be 1. And now let's convert this division into multiplication. So let me write over here S plus C over C, and this is C over 1, and then just do the cancellation. The C and the C cancels out, and I'm left with S plus C, and that's quite easily done. So QED, and that is what we write over here. So I think you deserve this thing when you solve such a nice question. So let me just focus on this. This is one, that's the original question, but written separately. So first, second, third, fourth. So it took 4 steps to solve this out. Quite easily done. Let's move ahead to the next part. So let me copy this question and let me add a page over here. Now the second part, it says, hence solve this equation. Now this thing over here equals to this. So basically we equate this with this and we solve for this. So over here, this thing equals to this. So therefore this equals to this. So therefore sine x plus cosine x is equals to 3 sine x minus 2 cosine x, and x lies between 0 and 2 pi. First simplify, and then sine minus 3 minus 2 sine x minus 2 minus 1, that is negative 3 cosine x, and then divide both sides by cosine x, divide both sides by cosine x, cancel the negative, therefore tangent x, 2 tan x is equals to 3, therefore tangent x is equals to 3 over 2. From here we will start working. So let me just focus over here, that is tangent x is 3 over 2. Now these are other ways that they're working it out. We don't have to. This is all good, all clear, and we will work this out this way. So now people, let's resume back. There was some electricity issue. So now we were looking at this answer. Tangent x is equals to 3 over 2. That is the method that we are working with. So tangent x is 3 over 2. So let me go to my calculator. And it's in the degree mode. Hold for a second. So this thing is gone. You see, tan inverse of 1.5 in radian mode. This comes out to be some issue. Tan inverse 1.5, and this is 0.9827. So that is the basic angle that we will use. So now the first step is the quadrant, that is first and the third quadrant. The next step is modification of range. There is none because it's x written over here and it's x written over here. So x lies between 0 and 2 pi. Is it inclusive? Yes, it's inclusive. The next one, let alpha be the basic angle. Tangent of alpha is 1.5. Therefore, alpha comes out to be 0.9828, correct to 4SF. And now we are working for first and third quadrant. So therefore, x is equals to first quadrant 0.9828, and the third quadrant, that is pi, which is 3.142 plus 0.9828. So therefore, x is 0.983, that is the 3 significant figure rounded off value, and the other value is 4.12 or 13. Now let me check what value am I getting. 98, hold for a second, let me convert it back. Let me go to the basic calculator. 3.142 plus not this, 0.9828. So therefore 4.1248, this comes out to be 4.1248, 4.12, I think 4.12, that is the answer, given correct to 3 significant figures. So I'll stick with this answer, 4.12, scratch this thing off. So that is the answer for this part. Now another question. It says again it's in radians. So this is in radians. And let me highlight this thing in blue color. It's between 0 and x. It says show that 3 sine x tan x, 3 sine x tangent x minus cosine x plus 1 equals to 0 can be written as a quadratic equation in cosine x. So tangent x will get substituted first, that is sine x over cosine x. And let's continue the journey. 3 sine x over cosine x minus cosine x plus 1 equals to 0. Now let's take this cosine x and let's multiply it out. So this will multiply with this will multiply with this. So therefore this is 3 sine square x minus cosine square x plus cosine x is equals to 0. The second step is convert this cosine square x. So we know that sine square plus cosine square equals to 1. Therefore cosine square is 1 minus sine square. So this is negative. This is 1 minus sine square x. And this is cosine x. And this is 3 sine square x. Let me simplify. 3 plus 1, that is 4 sine square x. And this is plus cosine x minus 1 equals to 0. Let me double check. 4 sine square x plus cosine x minus 1 equals to 0. They have not written the 3-term thing. So let me just double check my working. That is again over here. 3 sine, tan is written as sine over cos. Sine into sine, sine square, perfect. This negative cos is right over here, plus 1 is right over here, cosine into cosine, that is cosine square x, cosine x into 1, that is cosine x. Minus is there, cosine square is 1 minus sine square, this minus 1 goes over here, and this minus and minus becomes a plus, that is 4, 3 plus 1 is 4, good, plus cosine minus 1 equals to 0. This is... we want it in terms of cosine. My bad. We don't need to change this. So I got a little bit carried away. So now this is 4, 3 sine square x. And this is minus cosine square x plus cosine x is equals to 0. We need to convert this thing. So now sine square is 1 minus cosine square. So therefore sine square is 1 minus cosine square. So this is 1 minus cosine square x. Now it's all good, all clear. 3 minus cosine square x plus cosine x is equals to 0. 3 minus 3 cosine square x minus cosine square x plus cosine x is equals to 0. Minus 4 cosine square x plus cosine x plus 3 is equals to 0. 4 cosine square x minus cos x minus 3 equals to 0. I think that is the quadratic that they are talking about. So the first part is done, and hence it's just one big part, 5 parts. So now let's factorize. So 4 cosine square x minus 4 cosine x plus 3 cosine x minus 3 equals to 0. This is middle term factorization. 4 cosine x minus 1 plus 3 cosine x minus 1 equals to 0. Therefore cosine x minus 1, therefore 4 cosine x plus 3 equals to 0. In other words, cosine x is equals to plus 1. Let me not write plus 1, just so 1 is enough. And over here, let me write cosine x is equals to negative 3 over 4. Now, if cosine x equals to 1, what should I do? So let me just grab this thing over here. If cosine, not this thick, if cosine x equals to 1, what I can do is that, let me draw the x-axis like this. Let me draw the y-axis like this. Let me draw the graph and let me draw it like this. And let me stop it over here. So this is 2 pi. This is pi. This is 0. This is 1. This is negative 1. So 1, 2, 3, 4, 5 major points, and the range is between 0 and pi. So between this range, between 0 and pi, when is cosine x equals to 1? So I'll write x is equals to 0 radians. X is equals to 0 radians. And then the next one, that's right over here. And are they talking about -1? No, they are not talking about -1. Let me proceed with this. So cosine x is -3/4. So I'll write second and third quadrant. And then x lies between 0 and pi. Let me double check. X lies between 0 and pi. That's perfect. It's inclusive. And then what else is there? We have this thing. I need some more space. So we have this thing which is cosine alpha is 0.75. Therefore, get me a value of this thing. Scientific calculator, radian mode, cosine inverse 0.75 equals 7227. 0.7227. Therefore, x equals to, in the second quadrant, pi minus 0.7227, and in the third quadrant, pi plus 0.7227. Now what is pi? Pi is 3.142. So this is 3.142. Remember, pi is 3.142. So again, the basic calculator, 3.142 minus 0.7227. This comes out to be 2.4193, which will simplify to 2.42. And this is again 3.142. So 3.142 plus 0.7227. This comes out to be 3.8647. This comes out to be 3.86. So this is the answer, this is the answer, this is the answer, and that's how this question is done. So I think let's stop over here. So we have done radians, we have done degrees, we dealt with radians, we dealt with degrees, we solved a lot of trig equations in which simplification was there and trigonometric identity was also there. So all good, all clear. See you in the next class.